big issues on the southern coast of Western Australia is the risk of erosion from the strong southwesterly swells and storms. We focused our research in Albany, a seaside town which relies on a stable coastline for its livelihood. It's important to understand and protect these beaches for the social and economic future of Albany. Beach erosion is affected by factors such as wave height and energy, beach slope, sediment grain size, as well as wind strength. We chose beaches of 4 different aspects to see how these factors interacted with the coastline. Middleton Beach is located near the town centre of Albany and is an integral part of the town's identity. Nannerrup Beach is more isolated, yet an iconic beach for surfers, fishers and swimmers alike. Frenchman Bay is a pristine, calm beach outside Albany's harbour. Finally, Tor Bay is an exposed southwest-facing beach, however not easily accessible, so we used Ismith Bay as the representative of a southwesterly-facing beach. These beaches were identified and chosen based on the prevailing directions of waves and wind. We went into the field to measure beach profiles using a Trimble GPS system, which accurately records your position at any point within centimetres. A minimum of 3 transects recorded at each beach, starting at the top of the first dune and finishing in the swash zone. We recorded higher significant wave heights for the southwesterly facing beach at Tor Bay and Nannerrup, and smaller significant wave heights at Frenchman Bay and Middleton Beach. It was interesting because we found significant evidence of waves refracting in the direction of the beach. When we were walking along the beach, we could see which beaches had experienced greater erosion. This was clear by the width of the beach and the dunes that were present. When we analysed the GPS data from our beach profiles, it was clear that beaches facing a southerly direction suffer from a higher risk of erosion.
In this project, we aimed to investigating the sediment composition of 3 beaches around the Albany coastline. After we collecting the sediment from each beach, we did a sieving process to them. So we successfully separated the sediment by their grain size from 2 mm to 63 micrometers. After that, we transfer all the sediment to a drying machine to remove the excess water. After completing the drying process, we use a scale to weight them. And after that, with the help of the microscope and the paint brush, we classified the sediment either by lithogenic or biogenic. In conclusion, we found out all the beaches have the unique sediment composition.
The sediments that were collected off the boat for the deep water profile were collected with a Van Beam sediment grab tool, and this tool is pretty much a clamp which gets deployed off the boat and it gets lowered down to the seafloor. Once it reaches the seafloor, it gets manually retrieved, and the act of retrieving the clamp takes a scrape of sediments. These are then brought onto the boat. They're put into a marked bag and a GPS location is taken from that point.
We used the tow camera to determine the habitats and how the habitat changed with depth. This was followed by plotting the depths against the cumulative distance between the waypoints in order to create a depth profile. Overall, the results that we found include that the sediment production was influenced by different benthic habitats, which ultimately changed with depth. The 3 benthic habitats that were investigated include seagrass meadows, sandy and rocky habitats. Interestingly, the critical depth value for seagrass was found to be 20 metres, which is found to be consistent across the 3 different locations. It is also important to note that there are more carbonates produced in the seagrass habitats, which were predominantly located at Frenchman Bay. Larger sediments were produced in the seagrass habitats, however the sediment was found to be trapped in the seagrass and not transported onto the beach.